NEC Table 310.16 is used to determine the ampacity of a conductor carrying a continuous load, which is then used to select a conductor that is properly sized for that load. This is necessary because the ampacity of a conductor is not the same as its size. The ampacity of a conductor is determined by its physical characteristics such as its material, cross-sectional area, and insulation, and it is expressed in amperes. The size of a conductor is determined by its cross-sectional area, and it is expressed in AWG, American wire gauge, or kcmil, 1000 circular mils. For example, a 10 AWG THHN conductor has an ampacity of 30 amperes for a continuous load when installed in a conduit or raceway at an ambient temperature of 75 degrees Celsius. However, if that same conductor is installed in free air, its ampacity is only 25 amperes for a continuous load. This is because the free air surrounding the conductor does not provide as much heat dissipation as the conduit or raceway, and the conductor will therefore run hotter at a given current. In the example provided, the 104 ampere continuous load is multiplied by 125% to arrive at 130 amperes. This is because the NEC requires that conductors be sized for a minimum of 125% of the continuous load that they will be carrying. This is done to provide a margin of safety and to ensure that the conductor will not overheat and fail under normal operating conditions. Therefore, the reason why you are increasing the ampacity of a conductor for continuous loading is to select a conductor that is properly sized for that load. The ampacity of a conductor is determined by its physical characteristics, and it is expressed in amperes. The size of a conductor is determined by its cross-sectional area, and it is expressed in AWG or kcmil. NEC Table 310.16 is used to determine the ampacity of a conductor carrying a continuous load, which is then used to select a conductor that is properly sized for that load.